This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and I have the honor to talk to
Peter Sieber. Good morning, good afternoon,
good night,
day, wherever you are.
You recorded a very interesting episode with two guys from Zeiss.
Right.
They will explain how they use machine learning for their optics, right? It was optics.
Yeah, that's right. Yeah, that's the optics division. Yeah.
Okay, but first we have the news part. I will start with the news today. But by the way, you were at the chess tournament. How was it?
Was I? Oh, it was very interesting. Very interesting. Yeah. I mean, like many people, maybe also some of our listeners, although they are separate topics, but then many times chess and artificial intelligence, they kind of overlap. And
sure.
I, as so many others, what was the movie was called Queen's Gambit. I don't know if you've seen it. It was that a year ago, and and that's what they were explaining. So they teach chess online, but this single time there was this young grandmaster, German guy, Huschenbit, and it was very interesting. And yet to bring the combination to our podcast, whatever chess you play today, unless you do it over the board, without any electronics, AI is always let's say the golden standard. It's always showing and deciding which of the two, black or white, is winning. And that is for everybody, including the top world players, the number one world player. None of us will ever win again, against artificial intelligence chess engine. So yeah, bottom line, very interesting to be with human beings though, again, although I do like playing against chess bots as well. So that's another piece of artificial intelligence, which try to become human. We'll talk a little bit about this later on as well, I believe. But for me, it was very interesting and good to see humans playing chess.
Let's start with our industrial AI part. I have a very interesting project I found at the University of Hamburg. It's a project engineering for AI-based automation in virtual and real production environments. Mm-hmm. It's by DTech and by Professor Oliver Niggemann, Professor Alexander Frey. They wrote it's making initial progress. And as a part of the project, an open, expandable engineering platform is being developed that enables the integration of AI in engineering. The partner in this project is Weidmuller. We already talked with the Weidmuller guys about the AutoML tool. But I think that's a very interesting approach because we have had it before that engineering is a very big challenge and when dealing with AI in industrial processes. So I will put the whole paper from Oliver Niggemann in the show notes, and the listeners can read the paper. It's very interesting, this project. Okay. AI-based automation in virtual and real production environments.
Maybe you want to ask Oliver. He was in our show before, Professor Niggemann. Yes. Maybe you want to ask him sometime to
explain these. I think it's very interesting because it's an open source project, expandable engineering platform. I think that could be very, very interesting.
Yeah, a combination of artificial intelligence with and embedded into engineering. Very important.
Because it's very, very difficult, I think. You can have some proof of concepts, but to bring the AI in real time, it's very difficult in the industrial field.
Yeah. Well, my hypothesis that whatever we're going to embed artificial intelligence into automation systems, and our complete world of automated systems today is rules based. From coffee machines to airplanes to whatever. Yeah. And my hypothesis is we're going to include artificial intelligence into these systems, but on the outside where the rubber meets the road, so to say, I think we're always going to keep rules based kind of controls. Yeah, basically controls, because, we cannot leave the final decision, does the plane go up or down or left or right, as an example. We cannot, I believe, that's my hypothesis, we cannot leave that to the artificial intelligence. We always need rule-based checks if whatever we have learned better than before from embedded artificial intelligence, if it makes sense what it is proposing to us. So.
Sure. My second news is today the public hearing on the European AI Act is taking place in the German Parliament.
Oh, wow.
And I read an article in the Tagesspiegel background, and there are 8 experts that are giving their opinion on the certain draft. Most of them criticize the underlying AI definition, saying it's too general. And what I miss in the article by the colleagues is the industry is missing. There's
Really?
no person talking for the industry. I wrote an article with the colleagues from Applied AI in Munich. We have to invite somebody from Applied AI, I think, to talk about the AI Act and the discussion, because it's very, very important for the European Union.
I was going to ask if you had recognized, if we know any of these people that are talking there today, but it's not, and nobody from industry, you say?
It's Algorithm Watch is there,
okay.
some unions, and there's a AI Association of Germany, but there's no industry.
Yeah, well, there's no VDMA, so the German Association for Machine Builders.
In the article, I must maybe they're in the hearing, but in the article they're
I understand. Yeah, because I mean, already a long time ago, like a year ago, both VDMA, the German Machine Builders Association, ZVEI for what are they? Electronics Association. They both had we've had them in our podcast, and they could share their vision and opinions. Oh, very much looking forward to. So but that is then now for Germany, and is that then being fed up to the European level?
Yeah, sure. Yeah, the hearing, and it will be fed up to the European level. Yeah.
Okay. Yeah. Looking forward to it.
And my third news is a rumor. So we have one rumor in this news. SoftBank eyes strategic alliance between ARM and Samsung. This article is written by Anton Shilov and Masayoshi Son flies. He wrote Masayoshi flies to South Korea to discuss strategic ARM Samsung tie-up. I'm looking forward to the trip, Son said through a SoftBank spokesperson, according to Bloomberg. I want to discuss a strategic alliance from ARM with Samsung. So we have to be a little patient, but it's very interesting that we have a cooperation or a strategic alliance from ARM with Samsung.
I do not immediately understand. My brain doesn't immediately understand what that means, but we see so many. We have, a European chip act, and then the United States has one, which really means, chips need to be manufactured on American soil, I believe, right? And then we have Intel, building 2 fabs, huge fabs in Dresden. And there's so much happening there, and they're all jockeying for and rather keeping their arms around, let's say, their specific chip capabilities, right? Yeah, I have one piece on silicon as well.
Okay, so let's start.
I look at Gartner quickly. I saw an article news on AI from the 2022 Gartner Hype Cycle. Hype Cycle, most of you know, is this graph that starts with an innovation trigger, then it goes to the peak of inflated expectations through the trough of disillusionment, and it moves on through the slope of enlightenment, plateau of productivity. I don't know who has ever come up with that from Gartner, but I think it's still a wonderful thing. It's a wonderful thing that you can always look at. And then they look at probably, I have no idea, 20, 30, 50 or 100, technologies, and they put all these things on that specific line. So what they say is they see their innovations, AI innovations, in 4 categories. Number 1 is data-centric. That's interesting. I talked about it 2 weeks ago. That was, you remember, Andrew Wang's data-centric approach. Still looking forward to, if ever somebody hears, we would like Andrew to come and talk to us about his data-centric approach. So that is no coincidence that Gartner is saying something similar. A sub part of that is the synthetic data, that is, avoiding using personal identifiable information. We already did an interview with Philipp Sluzelek. You recall, German Research Center for Artificial Intelligence, DFKI. That's about a year ago. And I still need to meet with Ashish Chandavarkar. He is from a Munich startup, and they're called Synthetic Images. So if we're probably going to meet for a coffee, and it sounds interesting because it is likely going to be on the topic of synthetic images.
Yes, sure.
If that's the name of their company is. Number two is a model-centric AI. So despite the shift to the data-centric, Gartner sees innovations in physics-informed AI, composite AI, causal AI. That's one that I've seen a lot. It's always about, relations, causal or not. Generative AI, that's all the DALI and what's happening there, I guess. So that's where they see things. Number three, they talk about applications-centric AI. There's a lot of terms here. Model ops that we talked about, NLP, autonomous. So I'm not going to go into the details there. And then they have the fourth category, human-centric AI. That includes AI trust, risk. That's what the hearing today is about, because in the end, the European AI Act is all about, providing trustworthy AI. And there's a new acronym here. It's called TRISM. Risk and security. What's the T stand for? Not me neither. But here it is, the responsible AI. So for who wants to see the details, you can find it at Gartner, I guess. Clients, of course, get all. But sometimes they make these available as well. I haven't read through the details yet. Second one I have is that Europe's, they say, fastest commercial AI data center. It's called Alpha One. Not sure why they do that, because, we've had some alphas, DeepMind. I'll come to DeepMind in a moment as well. But nevertheless, that's how they call it. Alpha One was officially launched. It's located in the Bayreuth area, which, most of us know for the yearly Wagner Festival.
You have ever been there?
No, I haven't been there, no.
Okay.
But I know from the fact that our former chancellor would always go there, right?
Yeah.
And I think she still goes there. Have you been there?
No, I have never been there.
Haven't been there,
But I know that our guest, Frank Meyer from Lenze, the CTO from Lenze, who will visit us in October with our event in ZEP, he is always there in Bayreuth.
Okay.
Yeah.
We'll see each other next week, I believe, right? Yeah. We can ask him then. So the private operator is this Alpha Layers GTS. They are a wholly owned subsidiary of Heidelberg AI startup Aleph Alpha. That's where the name comes from. I'm not sure if I pronounce it correctly. Aleph PH. They built the data center together with HPE, Hewlett Packard Enterprise, and NVIDIA. Financing comes entirely from German European investors. That's untypical.
Yeah.
There is 512 NVIDIA A100 GPUs for those of you interested in the details, which gives the thing a max cluster performance of, I believe it's 7.625 petaflops, whatever. Huge number. Nevertheless, it brings him not further than ranking 72 in the list of top 500 fastest supercomputers. So some way to go, but nevertheless, I think we say congratulations to a great start for such AI power to be accessible in European languages. That's one specific thing. And I quickly looked again to who is this Aleph Alpha. Yes, it is a difficult name for me to pronounce. And they say on their website, which brings me then to my final topic, they want to be the leading European company researching and creating next generation strong artificial intelligence.
That's your topic.
Oh my God.
That's your topic, Peter.
Oh my God. And that's bringing me to my final point. And you've probably seen it. I think most people have seen it, but I haven't seen many people comment on it, and I don't understand why. Because I say, oh no, not again. Artificial intelligence will likely destroy humans. researchers say. Yeah, I can't really hear it anymore. But the problem is these researchers are not just anybody. They are from Google and they are from the University of Oxford.
Yes.
Specifically DeepMind Markus Hutter. I think I've heard his name a couple of times before. And Oxford researchers Michael Cohen and Michael A. Osborne. Yeah, I mean, it's the Markus Hutter. He's not, we had a Hutter that we know as well from Automel. Or do I mix up names?
Yeah, it's Frank Hutter.
That's Frank, right?
Yeah.
Yeah, so I'm not sure if Marcus is a family member or whatever. Now the point is what I do not grasp. And dear DeepMind boss, dear Demis Hassabis, I highly respect you. I believe you, if you're listening, or if one of your colleagues is listening, I believe you are one of the global, let's say, top 5 AI most knowledgeable persons that I know. And I would like to know if you are aware of what your senior scientist has published. And I would be very interested in, if you could please share with us somewhere, as, in answer to the question by Peter from the Industrial AI podcast, to the long-standing question, because that's how it was put, of whether a super intelligent AI may go rogue and wipe out humans, and assuming that in your case it is not likely, because that's what these researchers say, right? They say, yes, likely. And if I see a thing like that, and if you and I, starting out with a podcast, and there's hundreds, thousands of us, working with algorithms that, sometime have been called, AI, machine learning, and we do good things with them, and we explain the community, the people out there that, have no idea of what it is. Then again, come these researchers and say, they're going to destroy us at some point in time. So that is not good. I myself, in all humbleness, I'm convinced that if humans are going to be wiped out, it will be by humans and not by extraterrestrials or by any super AI, but humans. For which reason I am, certain that we need to be not afraid of AI, but we need to keep an eye on humans. And for that reason, we do need to restrict and authorize AI applications. And then we're back to the hearing that you talked about today. Sure. So yes, again, I'm certain that at least we know from VDMA, from, I believe, ZVE less, that they were not happy with the classification of machines, for example. And I'm not saying that I do in detail. I just say that at the level where, things might go wrong, I think it's very important that we do deal with artificial intelligence as a technology similar to whatever, more than water or gas or electricity, as, Andrew Wing has been saying. It's more like nuclear power, I would say. We have to. But then again, please do not misunderstand me, listeners. It's not saying that for that reason, each and any application that has machine learning in it, is bad. And that's not the point I'm trying to make here. So
you are the human-centric AI evangelist or preacher man, I could also say.
Yeah, maybe.
Sometimes it's loud like a preacher man. Yeah.
Yeah, could be. Yeah, maybe I should become politician.
The first minister of the Netherlands from Bavaria.
Yeah, who knows? Let's see.
Thank you very much, Peter. Let's start with our two guys from Zeiss. It was a pleasure to talk to you, and to all our listeners. Enjoy listening the main part with machine learning in the optical industry. I'm not a professional in this industry, but I listened to the episode, and it was very interesting.
Yeah, it's a very interesting approach they take to improving their overall equipment efficiency. Yeah.
So thanks a lot, Peter. Greetings to Munich.
Thank you, Robert. See you soon, and cheers to our listeners. My guests today are Jens Bürgin. He is head of Industry 4.0 at Zeiss Vision Care, and Kai Kümmel. He is the program manager data and analytics at Zeiss Group. And we will discuss today the very interesting sounding topic of Markov-based predictive quality analytics for mass lens production at Zeiss. Hello, Jens. Hello, Kai.
Hello, Peter.
Hi, and good morning, Peter. Thanks for having us.
Yes, please tell our listeners, who are you, where are you from, and what do you do at Zeiss? Jens, maybe you want to start?
Yes, sure. I was working as research associate at the Karlsruhe Institute of Technology, where I was managing research and consulting projects in the area of Industry 4.0. And after it, I was joining Mahle, an automotive supplier, for optimizing the production of mechatronics components. And then I was also there managing in the Industry 4.0 program in the electronics and mechatronics business unit. After that, I joined Zeiss, as you introduced me, as head of Industry 4.0, also managing the Industry 4.0 program and developing Industry 4.0 technologies at Zeiss Vision Care across different departments in Zeiss Vision Care and in cooperation with other colleagues and institutions at Zeiss, like the Zeiss Digital Partners, where Kai is coming from.
Very good. Kai?
Yeah, thanks. So from my background, I'm a mathematician. I did my PhD in probability theory, and I focused on the dynamic of random systems. After that, I applied it mainly for machine learning and data science, both in the financial and the industry sector. And as already mentioned, now I'm in a shared function at Zeiss, focusing on data and analytics, and there I'm a program manager.
You both mentioned separate divisions that you have been or are working at. So maybe you want to give us a quick company Zeiss introduction overview.
Sure. Zeiss as a company is operating in the fields of optics and optoelectronics and is structured in 4 segments. As part of the consumer market segment, Zeiss Vision Care is one of the world's leading manufacturers of eyeglass lenses and ophthalmic instruments. And Kai, you could say something about ZDP.
Sure, yeah. ZDP, or Zeiss Digital Partners, is a shared function, as I mentioned, focusing mainly on digitalization as a whole, and has one focus area in the field of data and analytics. And this is the division I'm working in.
Okay, and the topic we talk about today sits within the Zeiss Vision Care and with the support of you, Kai, within the Zeiss Digital Partners, right?
That's correct.
Right. Yeah.
Well, today's topic is Markov-based predictive quality analytics for mass lens production at Zeiss. So let's start with a short introduction and maybe best from the end. Jens, if you could tell us a little bit about lens production. So what kind of lenses are we talking about and how are they being produced?
We're talking about eyeglass lenses. Zeiss Vision Care, for which I am working and where this business case comes from, sells about 120 million lenses per year, serving 60 million customers. Our production is organized globally with more than 200 locations and more than 10,000 employees. And as you can imagine, to produce such a high number of lenses every year, our production is a mass production, which is highly automated, but producing individualized eyeglass lenses. How can we do this? We use freeform technology to surface the backside of each lens. And this freeform technology was developed by Zeiss and introduced in the year of 2000. With this technology, we can create the optical characteristics optimized for the prescription of each individual customer.
Okay, we're not going to go into the details of the freeform, but I may assume that you probably have a patent around that kind of technology.
Yes, exactly.
Okay, so as we're going to be talking about further improving quality, let's first look at how you have been measuring quality until today.
Internally, we measure the yield of our production, but in the end, we want to deliver high quality lenses within a short delivery time, meaning only good lenses are delivered to customers. But of course, internally, and that's why we measure the yield, defect cannot be 100% avoided. And that's why we have to work on this topic, because defects means that we have to often scrap the lenses which are defect, and we have to restart the order again, which has a negative impact on our cost because you need to scrap the lens, and a negative impact on the delivery time.
Right. We've talked about approving OEE, overall equipment effectiveness, for a couple of times, and we're not going to talk about the exact number here. That is completely not important. Although of course everybody is always interested to know what number the other companies have. But I've made the statement a couple of times that if we don't make sure that we improve our OEE, let's say towards 90x plus, somewhere towards the direction of 100%, then it's almost like useless to start doing data science or artificial intelligence, because we will always come back to the problem of too high scrap. So and now you want to further improve your OEE through Markov. Now, we have learned about many different approaches in the last years, about doing quality improvement of OEE, but we have not heard yet about the Markov chain. So please explain what is Markov? Tell us a little bit about your development environment, maybe in relation to Markov. What is the kind of data? What is the kind of training, etc.? Kai, can you do that?
Of course, yes. So generally speaking, Markov chains describe an approach which you can use to model a process that is under the influence of random perturbations. So let's assume you have an object, and this object can be in different states. And now you're interested in when is it maybe in a state that is intact, or maybe when it is in a state that means defect, in the most easiest way. And in Markov chains holds a key assumption of being memoryless, which means that when you want to describe the dynamics or the probability of being in a certain state tomorrow, it only depends on the state where you are right now, in the present. And what you do not need to map the future is you're not interested in the past. So you're not interested in which states you were in before you reach the state as of today, but you're interested in where you are right now. And this is all information that you need to model your future states that you can be in, and the dynamic distributions you are in the future. And then this key assumption makes it rather easy to apply. So this was one reason we selected Markov chains. So it's rather easy to apply, as you are mainly using information from the current state for your future. But although it sounds rather simple, it still can provide really strong insights on how your process is working, how your process is moving, and which states you are in most often.
Okay, we don't want to go into too much detail, but I'm just interested in, you have, together with colleagues, I guess, or you by yourself, decided that you're going to go for the Markov chain out of a range of different approaches. And so do our listeners, when they're dealing, with their situations. Can you share, one specific reason why? I mean, in general, I can assume, people, come from a specific area. You studied mathematics. Maybe that was your favorite topic, or there's a reason, from within the team, or what can you, maybe you cannot, and that's okay as well, but can you share maybe one specific reason why in this specific case, or maybe in general, you like to use Markov chains?
Well, I do like many different model approaches. So I just like modeling processes. In this case, often it turns out that not the most complex modeling approach is the one that provides the most benefits.
Very good.
In this specific case, it was quite some work to put all information, put all the data that we need in one place, in the right structure and the right quality. There is when you're working with data, of course, sometimes there are some inconsistencies that you come along when you use them. And as this was one of the first ideas, we had a lot of time to put the data in the right place, in the right structure, to understand the data properly. And then we put Markov chains on top, and they were able to basically answer many of our questions, still being a rather well understood and rather handsome approach. And as you might hear a bit later when we give our talk on the conference, there are specific questions we wanted to ask, and Markov chains were really capable of answering them, but we needed to slice them in the right way. So it's not that you can say, I have a bunch of questions and Markov chains are the answer to all of them. You have a bunch of questions, and then you focus on some of them. It turned out that Markov chains are really capable for the most important questions for us. However, there are some other questions where we might need to switch the approach eventually. But as of now, we are, I think, quite happy to select those and use them so far. And on a side note, maybe they are really well studied. So it's honestly speaking, there are really well established frameworks and packages available. So in your day-by-day life, it's making your life much easier when you can rely on established packages, as we did in Python, for instance.
Sounds very good. I mean, I like your approach. First ask your questions, or be sure that you know your questions, and then choose your approach, rather than, as you said, it doesn't always have to be the most complex. We do not always need, deep reinforcement learning or any wonderful thing, again, without any giving any, complexity or reason for one or the other. Jens, maybe you can add some information about the data used for feeding the Markov chains.
So the data used is data which is generated in our production system, and we thought the Markov chain would be helpful to analyze this data together with Zeiss digital partners to use each process step in our production line mapped as state in the Markov chain to see whether the lenses which are scrapped, so where the defects are detected in the chain, in the process flow, in the process steps, and to see where these deviations occur from the standard process flow. So where the lenses are taken out from the usual production flow and are restarted because of defects, and to see for different defects the different process flows in the Markov chain.
Very good. We're not going to go into more details here. Kai, you already referred to the presentation two of you will be doing, I guess, later on in this month. We'll come to that later in Berlin. For the moment, let's talk a little bit about your team. How many are you? What do they do? Are you looking for colleagues to join the team? And if so, what should they bring to the team?
My team, the Industry 4.0 development at Zeiss Vision Care, we are 5 colleagues, including myself. We are working on collecting data, connecting machines to collect the data, also on traceability to trace each individual lens through the production even better, and automate also our inspection of the lenses with artificial intelligence. And then, of course, finally, but not least, analyzing the data we have collected, bringing our production to a new level, as I explained in the example before, to improve our quality. And yes, of course, we are looking for new colleagues, especially in this field with background in quality management and data analytics.
Very good, Kai.
Yeah, of course, also on the corporate data analytics side, we are looking for more colleagues to join. There are positions like data engineers, data architects, also experts for machine learning as well as data governance. As you might imagine, there's a lot of work still ahead of us, and we are still looking to grow.
Very good. Maybe you want to quickly say, both Jens and Kai, what does that mean? Where would people, if they would be interested in hearing what it is that both of you are working on, where would they be based? Jens, in your team, or Kai, in your team?
So in my team, we are all based in Aalen, in our lab in Aalen. It is a global lead lab for eyeglass lenses production. And we would be based here together.
Okay.
We do have colleagues in different locations.
Okay.
Some colleagues are in Munich, as I am. Some colleagues are in our headquarter in Oberkochen. And this is where most of the team is located.
Okay, coming to a close, where do you see developments regarding AI data science, technically or organizationally?
Yeah, maybe I can start. So I think there was a really good improvement in how to think about data when there was much more emphasis, or there is much more emphasis on data quality and accessibility than I think it was there 10 years before. So data is more considered as an asset. And by doing so, there is an understanding that it requires time, it requires work, it requires an invest into the data, the way you gather data, the way you maintain data, to make sure that you can have a sustainable use of data later on. And I think this is really good.
And from us in Zeiss Vision Care explicitly, our vision is to, in this topic, achieve a closed loop quality control, meaning that we can control our production even better based on data in order to avoid the scrap and reduce delivery time to our customers. When we're using the data to better understand our production, to be better predicting our production, and to have this closed loop to autonomously control our production based on data. So using information we gather on the shop floor related to optical characteristics, so the process parameters, the quality inspections data related to the optical characteristics, and use that data to make better decision autonomously in our shop floor to achieve our targets.
Great, Jens, Kai, thank you very much. Listeners that want to get in touch with you, we already mentioned, maybe they would be interested in joining you, or they have the one or the other question. We'll get to the presentation in a moment. But listeners can best contact you by LinkedIn. Both of you have a German U with 2 dots on it in your family name. I'll spell it out. So Kai Kümmel, you'll find on LinkedIn as Kai, and then Kümmel is Kuemmel. And for Jens, Jens, Bürgin goes like Buergin, Kai Kümmel and Jens Bürgin. Yeah, and as we mentioned, both of you will be presenting live at the Predictive Analytics World Industry 4.0. That is October 5th and 6th in Berlin. And listeners who want to experience you live, maybe talk to you on site, ask you questions on site, we very much look forward to welcoming you there. We'll put the URL in the podcast notes as well. Otherwise, if you, dear listeners, have any questions or comments, as always, please, send me a mail or contact me at LinkedIn as well, Peter Seberg. I'm glad you've stayed with us so far. Looking forward to have you with us next time. Jens, Kai, thank you again, and looking forward to be meeting you and seeing you in Berlin.
Thanks from our side, Peter.
Thanks a lot. Bye.